Okay, so in this video, we are going to look at permutations. And where we would have seen a question like this before from junior cycle would be something like this, where Jack has 10 shirts, 6 pairs of shoes, and 4 pairs of trousers. In how many different ways can he dress himself? And what we would do is we would multiply all the different options together. So we would get 10, because there's 10 shirts, times 6, because there's 6 pairs of shoes, so 6 options for the shoes, times 4, because there's 4 pairs of trousers. So you would always multiply the options, and you would then get 240. So there's 240 different ways that he can dress himself. So this is a classic example of what we would have dealt with at junior cycle. And now at senior cycle, we're going to deal with some more complicated questions to do with permutations. One of the key things that you have to remember with permutations is these are to do with arrangements, okay? And the thing with arrangements is that order matters, all right? So exactly what you put in each different position, if you like, determines how many different arrangements there are. And one little change in the positions will make a different arrangement. So order really matters here. And each time you change up the order, it does count as a different arrangement. And so all these questions are asking about how many different permutations or arrangements of things there are. We're going to jump straight into an example here to see this at work. Okay, so take a look at this. There are 6 different books, including a science book, on a shelf. And the first question is asking, in how many different ways can the 6 books be arranged on the shelf? So as we talked about in our example from what we might come across at junior cycle, this is all about multiplying your options. And if you have 6 books, I'm just going to put up 6 different positions, okay? And because we are multiplying our options, I'm going to go ahead and put my multiplication sign in between each of those positions. And then you want to consider, okay, if I have 6 books and I want to see how many different ways there are of arranging those, how many options do I have for that very first position, which would be the extreme left? And the answer is that you've got 6 because you have 6 books to choose from. Now, one book has gone into that position. How many books are left that would go into the second position, the options that I could choose from to go into that second position? And the answer is 5. And now there's 2 books in place. So how many options have I got for that third position? And the answer is 4. And for that fourth position, now that you have 3 books in place, 3, and of course 2, and then the last one. You'll have 1, when you've positioned obviously 5 books, you've only got 1 option left for that last final extreme right position, okay? And 6 times 5 times 4 times 3 times 2 times 1, when we have something like that where we're multiplying and the numbers are going down each time by 1, so for example, 5 is just 1 less from the 6, 4 is 1 less from the 5, 3 is 1 less from the 4, and so on. We can write this as 6 factorial. That's what it is called, and the notation is an exclamation mark. And we can do that on the calculator. Okay, so on this Casio, I'm going to press 6, and I'm going to press Shift, and I can see that the exclamation mark here is above the x to the power of -1 button. And if you press equals, then that is the answer. That is 6 times 5 times 4 times 3 times 2 times 1, 720. And that is the answer for part I. So factorial, just write a little note on it, is when you have a number and you're multiplying by 1 less each time all the way down to 1. So for example, what we've just seen there, 6 factorial is 720. And so any number, and if you're doing the factorial, it is that number times 1 less than that number, times 2 less, times 3 less, and all the way down until you get to times 1, okay? Multiplying by each of those numbers in descending order, that's what that factorial is. Okay, back to our example, we're going to take a look at part 2. So now we're being asked, in how many ways can the 6 books be arranged if the science book is always on the extreme left? Okay, so I'm going to set myself up with my positions. And of course, I'm always multiplying my options. And now I need to consider how many options I have for each position. Now, this is my extreme left. And since I now know that the science book always goes there, I don't really have any options now for that position because I know the science book needs to go in there, which means I don't have more than one option. I've only got one option for that position on the extreme left. So one goes in there. That's representing the science book. I know that has to go in there. I've only one option for it. Then one goes into that position on the extreme left. So now the science book is in place, which means I have 5 other books to choose from. And so I have 5 options then for the second position. And then 2 books are in place, which leaves me with 4 options for the next position. And then 3 times 2 times 1. So technically that is 1 times 5 factorial, because I have 5 times 4 times 3 times 2 times 1. And of course, on my calculator, that is, if I put that in, 1 times 5 factorial, I'm getting 120. Okay, let's have a look at this example now. How many different 4-letter arrangements can be made from the letters of the word Thursday if a letter cannot be repeated in an arrangement? And then how many of these arrangements begin with the letter D and end with a vowel? Okay, so one of the things with arrangements that you do always need to be mindful of is whether or not you can repeat things. Now, when you're moving around letters, it kind of is automatically understood that you're not going to be able to repeat, because once you move a letter and put it into a position, it's not available for any of the other positions. They did nicely clarify that for us in this particular question, but if they don't, you want to be very careful, as I said, in the context of the question, really think about, is this something where I can repeat things or I can't repeat things? Because obviously that changes your options. So we are moving around the letters in the word Thursday, and we want just 4-letter arrangements, which means I've only got 4 positions to worry about here. So I'm going to put my dashes for my positions. I'm going to put my multiplication sign in between because I know I'm always multiplying my options. Okay, so I have the letters in the word Thursday. So there are 8 letters in total there. So if I want a 4-letter arrangement, how many options have I got for that first position? The answer is 8. And then once one of the letters is in place, and it's obviously not available then to be repeated somewhere else, I only have 7 possibilities and options for the second position, 6 for the third position, and 5 for the fourth position. So this time, it's not 8 factorial, because 8 factorial would mean it would have to go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We're not quite going all the way down to 1. We're just going 8 times 7 times 6 times 5. Which works out to be 1,680. Now, the second part of this question is asking how many of the arrangements begin with a D and end with a vowel. So we're still talking about 4-letter arrangements because they haven't specified otherwise. So I'm going to put my 4 positions up there, and I'm going to put my multiplication sign in between because I'm always multiplying my options. Now I need to consider what options I have for each of the positions. If it must begin with a D, and there is only one D to choose from, which means there's only one option then for putting that D in place in the first position. And now the D is in place, it cannot be repeated. How many options have I got for the second position is what I need to consider. But first, because I do have another limitation here, it is always best to focus on your limitations first. Wherever the restriction is, deal with that first. So I've got the D sorted. Now I've got a restriction that it must end with a vowel. Now your vowels are A, E, I, O, and U. And I have a U, and I have an A, in terms of the vowels that I have in Thursday to choose from. So looking at that last position next, because it's my next restriction, I have 2 vowels to choose from there. So I've only 2 options. So I've got a D in there, and either a U or an A is going there. So 2 options at the end. Now you have 2 letters in place. Now how many options have you got for that second position? And the answer is 6. And now you have 3 letters in place. You have 5 options for that third position. So we have 1 times 6 times 5 times 2, which is 60. Okay, now let's have a look at this example. In how many ways can the letters of the word Scotland be arranged in a line? And then we're looking at in how many of these arrangements do the 2 vowels come together? And lastly, how many of these arrangements begin with an S and end with the 2 vowels? Okay, we have a few things going on here, but the very first question is just with no restrictions, how many ways can the letters of the word Scotland be arranged in a line? Now, they haven't specified here that the letters cannot be repeated, but again, it is implied in the context of the question. If we're going to move a letter into a position, it's no longer going to be available as an option for another position. So how many letters are we arranging? We've got 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to put my 8 options. 1, 2, 3, 4, 5, 6, 7, 8. And I'm a multiplication sign in between each of those. All right, so we've no restrictions in that very first question here. And Scotland, I've got 8 letters. And therefore, in my first position, I've got 8 options. And then when 1 letter is in place, I'm going to have 7 options for my second position, 6 options for my third position, and 5, 4, 3, 2, 1, which of course is 8 factorial. And 8 factorial on my calculator. Remember, shift and the exclamation point is what you're looking for in your calculator, equals 40,320. Now, for part I, in how many of these arrangements do the 2 vowels come together? Okay, the best way to think about this now when we have, for example, anything coming together in this question, letters coming together, think of the letters being on tiles that you're moving around, okay? So we have S, we have C. Now I'm going to deal with my 2 vowels at the end, okay? I then have T on a little tile, I have L, I have N, I have D. And since the 2 vowels must be together, I'm going to put the 2 vowels together on 1 tile, okay? Because they've got to stay together, and it doesn't specify where they've got to be. In other words, it doesn't specify in which position they've got to be in. So they can be at the start or be in the middle, or the only restriction is that they are together. Okay, so once I consider them to be together on the tile, and I'm then just worrying about moving around that 1 tile, I know that they're always going to be considered to be together. So now, how many things am I considering to move around in the arrangement? Well, I've got 1, 2, 3, 4, 5, 6, 7 tiles to consider moving around in different arrangements. So 1, 2, 3, 4, 5, 6, 7. And put my multiplication sign up in between each of them. So you see, I have 7 options for that first position. The S could go into that first position, or the C, or the T, or the L, or the N, or the D, or the O and A together can go into that first position. Do you see the way we're looking at this? So I have 7 options. And again, once 1 of those tiles are in place, I will only have 6 options then for the next position, and 5, 4, 3, 2, 1. Now, there is one extra thing I need to think about when I'm putting these 2 letters on the tile, and that is, because with arrangements order matters, the O and the A can go together on that tile like that, in that order, or it could be in the order where the A is first and the O is second. Whenever you have two letters, there are two factorial ways of arranging those two letters then on that tile. And of course, 2 factorial in this case is just 2. This one's a quite easy one to think about because it's either going to be OA or AO. But however many letters you have that must be together, that's how many factorial ways of rearranging those letters on that particular tile, keeping them together. So that's what I'm going to have to multiply at the end. So what I technically have here is 7 factorial times 2 factorial. And if I do that on the calculator, 7 factorial times 2 factorial works out to be 10,080. Now, the second part of my question, how many of the arrangements begin with S and end with the 2 vowels? Okay, so I've got 1, 2, 3, 4, 5, 6. I still have to have the 2 vowels together, okay? So again, I'm going to consider my tiles, and I've only got 1, 2, 3, 4, 5, 6, 7 tiles to move around. But this time I know that the tile with the 2 vowels on it together has to go into this last position. So there's only one option to put them in there. Okay, I'm going to put my multiplication sign then in between all of them there. And that's in place. It must begin with an S, which means I've only one option to go into the first position as well. So that's in place. Always do your restrictions. And then how many options have I got then for the middle positions? And I've got 1, 2, 3, 4, 5. So I've got 5 options for the second position, 4 for the third, 3, 2, 1. And of course, I do need to consider about those vowels. It doesn't specify the order in which the vowels need to go, which means it could be OA or it could be AO. So again, there's 2 vowels. Therefore, there's 2 factorial ways of arranging those 2 vowels at the end. So what I have here is 1 times 5 factorial times 1 times 2 factorial. So technically, that's just 5 factorial times 2 factorial, which is 240. Right, let's have a look at this question. In how many ways can the letters of the word Ireland be arranged if each letter is used exactly once in each arrangement? And then in how many of these arrangements do the 3 vowels come together? Okay, so again, we're arranging the letters. So it's automatically assumed we can't repeat once the letter is in a position. It can't be used again. How many letters have I got in the word Ireland? 1, 2, 3, 4, 5, 6, 7. So for that first answer, it's going to be 7 factorial. There are 7 letters, therefore 7 factorial ways of arranging those letters. So that, of course, is 7 factorial 5040. Now, the second part of the question, and how many of these arrangements do the 3 vowels come together? Okay, so what have I got? I've got or, L, N, D, and the vowels I, E, and A must be together. So I'm going to put them all together on one tile. Okay, now, how many tiles have I got to move around or to arrange? So I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have 5 options, therefore, for that first position. It doesn't say exactly where the 3 vowels must go, so it means they could be anywhere in any of the positions, but they just must be all together. So once I have them all together on the tile, I'm just considering moving around that tile. So I have 5 options for that first position, 4, 3, 2, and then 1. And then what I need to consider is if there's 3 letters on that one tile, how many different ways of arranging 3 letters on a tile are there? And the answer is there's 3 factorial, because that could be IEA or AEI and so on and so forth. There's actually 6 possibilities of rearranging the letters IEA on that one tile. So if you have 3 letters, that's 3 factorial ways. So what I'm doing in my whole calculation here is 5 factorial times 3 factorial. And the answer is 720. Okay, now I'm actually going to add in a question here, all right, because this is another thing that can be asked. And that is, in how many ways can we have the 3 vowels apart? All right, so we've considered what we do when we have to put things together. Now we want to think about what happens if things must be kept apart. Now, this is harder to think about because there are lots of different ways, for example, in which the I, the E, and the A could be separated. You could have the I at the start, and then maybe a different letter, and then the E, and then maybe 2 different letters, and then the A. Or we could just have a different letter, and then the I, and then a different letter, and then the E, and then a different letter, and then the A. Do you see, there's a number of different things that could mean those 3 vowels being separated. All right, there's loads of different scenarios. And so it'd be very hard to kind of think of each and every single scenario. So a much easier way to work this one out would be consider how many ways there are of those 3 vowels being together. Take that away from the number of ways of arranging the letters with no restrictions. And what we have to be left with are all the ways of the vowels being apart. So in other words, our answer for the very first part, all the ways of arranging the letters with no restrictions, take away how many ways they are together, and what I'm left with is 4,320. That is how many ways then that the 3 vowels must be apart. So anytime you're asked a question like that about things being kept apart, it is much easier to work out the options of them being together and subtract that from your total possibilities, and then you have to be left with all the ways they must be apart. Okay, let's have a look at this question. This is a common little type question where we're asked about codes, okay? So let's consider this. How many 4-digit numbers can be formed using the digits 0, 2, 5, 7, 8 if a digit cannot be used more than once? So no repetition, nice and clear for us there, in any number. All right, we're going to answer that first question first, and then we'll get on to parts I and II. Now we're talking about a 4-digit number, so that means our arrangement has 4 positions. Now we're talking about numbers, and these are the digits that I can choose from. So how many options have I got for that first position? Well, the thing with this is, technically, if we're talking about a 4-digit number, we can't have 0 at the start, all right? Or it wouldn't be a 4-digit number. So we can't include the 0 in our options for that first position in the context of this question. Really, the only options I have for that first digit is 1, 2, 3, 4. It could be either the 2, the 5, the 7, or the 8. All right? So be careful of questions like that. You've always got to think about the context and what works in that context and what maybe doesn't. Now, one of those numbers is in place. We cannot use it again. So now how many options have I got for the second position? Well, now I could have a 0. Yeah, it's okay to have the 0 now in the second position. only one of the numbers has gone into that first position, which then leaves me still, including the 0, 4 options for that second position. Now 2 digits are in place, which means it only leaves me with 3 options for the third position, and then only 2 options for that final digit in the arrangement of that number. So the answer here is 4 times 4 times 3 times 2. Which is 96. Okay, so watch that with numbers. Check if you can repeat or not, that's really important. And then also if one of the digits, most like the 0, if it doesn't make sense that that could work in one of the positions, then be mindful of that as well. Now, part I. How many of these numbers are greater than 5,000? Okay, so we're still talking about a 4-digit number. Now, if it's greater than 5,000, what do we know about that number? Well, we do know that if it's got to be greater than 5,000, definitely can't start with a 0. It also can't start with a 2. It could start with a 5 or a 7 though, or an 8. So it could start with a 5, 7 or 8, which means there are 3 options only for that first position. Now, one of those numbers is in place and we can't repeat, which means there are now 4 options for the second digit and 3 options for the third and 2 for the last. So that gives me 3 times 4 times 3 times 2, which is 72. And now part 2. And in part 2, it says how many of these numbers are odd. Okay, so for it to be odd, what does that mean? The restriction here is that it must end in either a 5 or a 7. So let's put up our 4-digit positions, and we'll start with our restriction, of course. If it's got to be odd, there's 2 options. It could be the 5 or the 7 here, can go into that last position. Now, either the 5 or the 7 is in place. How many options have I got for that first position? Well, only one of the 5 or the 7 is in place, which means one or the other is still up as an option to go into that first position. As well as the 2 could go into that first position, as well as the 8, but again, the 0 cannot go into that first position. So I really only have 3 options then for that first position. So we've either a 5 or a 7 here. I have one of the other letters other than 0 in place here, which then leaves me with still 3 options for the second position, because now the 0 could be here in that second position. And then 2 left for that final position to consider once we've dealt with our 2 restrictions there. So we've got 3 times 3 times 2 times 2, which is 36. Okay, the final thing to just touch on here with permutations is the button NPR I want to introduce to you, which is on your calculator. Okay, now here it is above the multiplication sign. Do you see that? Now, the time that you would use the NPR button on your calculator is really when they're only asking you about taking different objects or of them at a time. So it's a very specific type of question here. And it's not one that we've actually come across in any of the examples that we've done. But if you are asked that, for example, find the number of ways the 5 letters A, B, C, D, E can be arranged in a line when taking 3 of them at a time. And of course, if you're talking about 3 of them at a time, you can just do your boxes as they have here, or the dashes like the way I was doing, and just consider that there's 5 options for the first, 4 for the second, and 3 for the third. But the other way of looking at that is Obviously, if you're considering your factorials, you're getting rid of the last two, the 2 and the 1, because you have 5 letters, but you're only taking them 3 at a time. The 2 and the 1 is what's gone then from the 5 factorial calculation. So technically, you're doing 5 factorial and then dividing by the difference between the 5 and the 3 factorial to get rid of these here with these here. Okay, so that's the NPR calculation on the calculator. That's what that will automatically do. For example, if you have 5 letters and you're taking them 3 at a time, if I press shift and my multiplication sign, the P comes up, and then 3, I get 60, which is the calculation 5 times 4 times 3. So that's the only time you'd use that calculator button, is when you're arranging different objects, taking a number of them at a time. So you do need to be familiar with what the actual calculation is that your button does, in other words, the button on the calculator. But the good news is it's very easy to spot when that kind of question comes up, because it will use that terminology. Okay, and otherwise you can just consider, like the way we've done all the other examples, set up your positions and then just think about how many options you have for each position. But I just need you to be familiar with that button and familiar with the calculation.